hear you. Hello everyone, my name is Bertrand Richaud and I'm a water resources expert at DHI, and I have the pleasure to show you this portal that Oluf has just introduced in his presentation. So this is what we call here the Flood and Drought portal. It's a portal that has been developed as part of a project where the focus was transpondary basin. But of course, the methodology that we applied can be used elsewhere in the globe. And one of the first thing I want to show you is we have a portal which requires login access. So as a new user, you would have to register, and this can be done by clicking on the login and then register a new user link. When you click on this register button, you actually get access to a panel that lists all the continents, and for each continent you have the list of transboundary basin. All of them should actually be available here. Only some of them are already what we call in operational basin, and that means that we are already in our daily process retrieving data and processing data for these basins. So for example, the three pilot basin of the project have been already added, like the Volta basin. And if you do register as a new user to try the system, I would recommend to choose one of these operational basins so you can get access immediately to data. But you could select another basin, transboundary basin like Senegal basin, which does not appear as operational. There is no flag next to the name on the list here. Okay, but for the purpose of this presentation, I will log in as a user, and this demo will take place in the Volta basin. So you should soon see the map of the Volta basin on your screen. And again, what I'm presenting here is similar for other basin and other location in the world. When you first log in this system, you will be prompted to select your favorite product, favorite data. As Oluf mentioned, we have quite a wide range of data that we are retrieving from different sources, but maybe you would be interested only in some of them. So when you can also change these settings by going to the settings menu and access the full list of products that we have at the moment available, and activate the product you are interested in. So we have some rainfall products, we have some forecasts products, and then we have vegetation, soil water index, and climate change related products and other type down there. For the purpose of this demonstration, I have already selected the product I would like to show you, so I will simply update the settings here. So when this is done, the list on the left hand side is now changed with the product I have selected, and I can activate a product by simply selecting it on the left menu, and now my product is displayed on the map. The map is really the center of this system, and that's why everything is happening will actually be done through the map. We now are viewing data trim, rainfall data for the last available time step. This is 21st of November 2016, so pretty much near real time. And I can go through different times using my data coverage bar at the bottom. By simply clicking, I will display another time step here. I could also select a specific time. For example, I want to show you what was the rainfall in the Volta basin on the 23rd of June this year. So I can type in the text box, and you should soon see the rainfall pattern for that day. On the right-hand side, we have the legend that tells us, of course, what is the meaning and the scale that we are using for this product. So here we are viewing daily rainfall. Further to showing this data on the map, we also process it and provide it in a different format. For example, we can you can easily access to time series of this product by selecting the time series tool and clicking on the charts. In this case, we are going to view the area weighted rainfall for the entire Volta basin. It is possible to use this chart to then zoom in into specific years or specific months, and of course this can be downloaded as a CSV file, so it can be used in other contexts if you like. But we are not providing only data for the whole basin, but also for sub-areas. You can, for example, select among the 4 main sub-basins in the Volta. We have added this 4 main basins on the map, and by simply clicking on them, you can select them and then view now the area weighted time series for this specific. We are now viewing the OT basin in the Volta basin. Then we can also use this tool to select data for a specific location by clicking on the map or some specific key location in the basin. Another tool is actually the same product, but then resampled to monthly. For example, rainfall can be quite useful, not with the daily scale, but the monthly scale. So now you should see the monthly rainfall for the entire time periods and for the Volta basin. On the top of the black line, you can also see a red line. This red line is the long-term mean. If you look at this long-term mean, you can see it is the same every year. So this is the long-term mean, so the monthly average rainfall. If we zoom into a specific year, so now we are viewing the last year available, we can see for a specific month, let's say last October, we can see we are the rainfall pattern, the rainfall in the Volta basin is actually lower than the average. It is about 20 millimeter below the long-term mean. So this can be very easy way to compare rainfall pattern with long-term average. We are also providing a way to view this data in the form of a table. So this table is actually a summary of the entire data, so from the beginning to the end, and for every month we have some statistics here at the bottom, the average, mean and max value for each month of the year, and similarly for each year in the data set. Lastly, we have another tool here that is available, is what we call the raster file. This is simply a way to download this data as a netcdf file. So in case you would like to use this data for creating your own maps, you could download it and import this into a GIS environment to create your own maps. Now I will move on to some other products that we have made available here that I would like to show you. We have a rainfall forecast. This is a seasonal forecast provided by NOAA. This is the Climate Forecast System version 2. Another nice tips I would like to show you is you can anytime click on the product and get some more information, including a link to the source. So we are referring to the original product portal. And you can read more, of course, there. Again, here you can view this data as a time series or also resample to monthly. For example, here I will select the monthly forecast for the entire Volta basin. So we can see this is an ensemble forecast, so it is not just one line, but here we have actually 20 members displayed. So it actually shows us the spread of the forecast. This can be also viewed in the different way as what we call an envelope plot, so to show how this spread evolves with the time. And here we have in gray zone the area between the 25th and the 75th percentile. And the line is the median of our ensemble. Then we have vegetation products. So we are linking to MODIS datasets. This MODIS dataset, the normalized difference vegetation index, tells us about the greenness of the vegetation. So again, this is similarly to the other products, can be viewed on the map or view also the time series for the whole basin or for a specific sub-area. We are also linking to Copernicus product, the soil water index, that tells us about the soil moisture of the root zone. So this is, you can see different resolution for each product. We are preserving the original resolution of the product, and it varies from product to product when it comes to spatial resolution, but also temporal resolution. This product is, for example, a 10 daily resolution product. We have temperature products also from MODIS. So similarly, we can view it on the map, also time series, and download it. Then I would like to show you another product which is slightly different. This is JSON water level of large water bodies. So it detects large water bodies in the basin. And for example, here we have the Volta basin, the Volta lake, sorry, where we can view the relative water level relative to a reference point. And we can, for example, see how this water level has evolved in the past month. On the top of this data product, we are, as Olof explained, processing this product to actually compute some drought indices. And this is what I want to show you here by displaying the SPI 1 month, the Standard Precipitation Index. This is an index that tells us how rainfall has been compared to normal in with relative numbers. So here, for example, we have highlighted some red and blue areas in the basin. Red areas shows lack of rainfall compared to normal. Blue areas will actually show us that there's been more rainfall than normal. And again, this can be viewed as a time series, and for this specific index, values between are normally between -2 and +2. When we have negative values, it is because there is a lack of rainfall compared to normal. And when it is below -1, we normally we can say that it is start to point to a drought situation. We can see some time in, for example, 2015, where for the whole the average value for the Volta basin has been quite low, to -1.3. So these are the drought categories that Olof introduced in this presentation. Another way to show this is as a column chart. So this is similar to a time series. We have the time scale in the x-axis, and we have in the y-axis the percentage of the basin that is under a specific drought category. For example, for these events that I mentioned previously in May 2015, we can see that the large part of the basin was under a drought category. So this can be a way to highlight some events in the past. We are doing the same, for example, with vegetation data, where we are processing and we're able to show the deviation of the normalized different vegetation index compared to normal. So in the similar way, we can show this as column charts in time series like. So we can highlight also here, for example, that in June 2015, the vegetation has been impacted by the lack of rainfall that occurred a few months before. We are also working on some combined drought index. So for example, the vegetation health index that combines temperature and vegetation impacts. Further to this data and access to data which is useful to information decision maker, we are working on producing automated drought reports. So soon we will be able to provide to stakeholders an automated drought report that contains key information and that can be prepared on a regular basis with, for example, key tables and maps showing drought impacted areas. And then we are also working on some analysis tools which will be soon completed, and this tool will make use of the data to provide actually more information. We are working on hydrological models such as a rainfall runoff model and also crop water requirements. So the rainfall runoff model will make use directly of the climate data, but also climate forecast and climate change information to produce runoff information for specific catchments in the basin. And again, with the crop water requirements, similarly, climate information would be used both in historic but also in the forecast, seasonal forecast and climate change information. I think that was it for my presentation. I look forward to the questions from the audience. Yes, thank you very much.